my goal today is to finish all the work. In other words, let's finish solving differential equations. They're really all the same kind of question, and that is, here is a differential equation, which is linear. And we're going to solve it by essentially using this formula. Excuse me. In this question here, a version of question 4, do you notice that this is not in its standard form yet? That's typically the first step you need to do. Standard form is the derivative on its own plus a function of xy equals a different function of xq. So in this case here, what should I do to both sides to make it its standard form, to get it to look like this? What should I do to both sides?
Divide by x.
Okay, now you divide by x, I'll call it that guy. This fella here, I'm going to divide it by x, but write it like this. And this guy here, I'm going to divide it by x. Are we comfortable with that? Now, I can identify who p of x is. It's always this guy, and the negative is included. And I can also identify the q of x. And then the next thing that we do is we find what's called the integrating factor. And it's a little bit weird, but it's e to the power of the integral of p of x. In this case, it's e to the power of the integral of negative 2 over x. And that is, in fact, this fella. Your friend in these questions is algebra. Algebra is going to get you out of a whole load of trouble, but you have to realize that there are certain simplifications that you need to be aware of. That guy right now is not really very helpful. I can rewrite that guy in a much better form. Can anyone tell me what that simplifies down to? E to the negative 2 log x. I'll tell you what it's not. It's negative 2x. It's not negative 2x.
X to the negative 2.
Agreed. It might help if I wrote it like that. Does it look a bit more obvious that it's x to the negative 2 now? Right. E raised to the power of a log. They two are inverse functions of each other. So when they cancel out, the negative 2 is left. So we're good. The next stage is to solve the equation. So it's going to be 1 over the integrating factor, the integral of ix qx, and then add c. So it's going to be 1 over x to the negative 2, the integral of x to the negative 2 times q, which is x, dx, add c. And again, algebra is going to help us out here. Would you agree that 1 over x to the negative 2 would look much nicer as x squared? You agree they're equivalent? Now, x to the negative 2 times x, if you prefer x to the 1, that leaves me with this guy. And again, algebra is going to help us out. Yeah, that's the guy I've got. But if I'm going to integrate him, don't I have to think of him like that? Now, normally, wouldn't a power be the right way to do it? But if you're going to integrate something, x to the negative 4, x to the half, right? That's the way you should write it. But isn't this the exception to the rule? If I left it like this, if I tried to do the power rule, can you see the problem? It doesn't work, right? You add 1 to the power and try and divide by 0 is not. But when you write it like this, you now have your answer. And we are finished. And we call this guy a general solution to the differential equation because it's got a plus c in it. Are we comfortable with that one? Right. So basically, we're just doing more and more awkward ones, right? Ones that are harder to do. So my version of question 5 looks like this. And I'm looking at that guy and I've got a few things I've got to deal with. First thing is not, it's not in its standard form. This has to be on its own. Okay, it's not Y and X, it's R and T, but that's just letters, right? Think of R as being the Y and T as being the X. So as long as you divide both sides by T log X, you get this guy. I'm going to rewrite this guy in that format. And I'm going to take this guy and I'm also going to divide him. And one more line before I call this guy good. A little cancel with the T's here. So we're good with that. It's now in its standard form, the way it needs to be written to be able to use this formula. So that's step 1. Step 2 is identify the P of T, which is this guy. And the Q of T, which is this guy. Much uglier than the typical P and Q that you get. Much uglier. And now I'll find the integrating factor I of T, which is this fellow. And that guy I'm going to do over here. I'm going to find the integral of P of T dt. Okay, you have a decision to make here, and that is what technique are you going to use to integrate that ugly fraction? Matthew, what do you say?
U sub LNP.
I agreed. What made you think that's the right one? What was the clue in your brain that made you think that was the way to go?
The reciprocal of the derivative would be t, which would cancel out the t on the bottom there.
Right. When you look at questions like that, this is for everyone. When you look at questions like that, aren't your two main go-tos going to be integration by parts or U sub? Would you agree that's the kind of road that would be the most likely one? Right. I can't remember what it was. Is it something like section 7.5 or 7.8, where I gave you a whole load of questions just to practice finding what techniques to use? You're less likely to worry about an X sub in these questions just because the math is so ugly, right? So when you're doing these ones for homework, think, unless it's obviously a power rule or something, think U sub or integration by parts. Now, when you differentiate this guy with respect to T, you get him. And when you do the crossover, oh, you got lucky. The D of T is already isolated. So what do I have? I have 1 over T U times T du. The T's cancel. And that's a very nice integral, which is the natural log of U. And then you replace it and you get a really ugly answer. It's a natural log of the natural log of T. So let me go back here and say it's e to the natural log of the natural log of T. algebra again. What does that fella simplify to? What is e to the natural log of the natural log of t become?
The natural log of t.
Correct. That makes sense? Can you think of e in natural logs as inverse functions? When you have two functions, one which is the inverse of the other, happening one after the other, they essentially cancel each other out. You see that the thing that's left is log t. So that means we can now move to our next stage, which is the solution. It won't be y equals, it'll be r equals now. And it'll be 1 over I of t, the integral of I of t q of t dt. I'd say, right? It's essentially the same form. It's going to be 1 over the natural log of t times the integral of the natural log of t times this fella. And finish with an odd and we got lucky. The logs cancel. And so we now have 1 over the natural log of t, the integral of this fella. He's easy to do. For e to the t plus c. And I would say that there's really not anything that you can do to that in style points. That's probably as good as it's going to get. So the solution to this differential equation is any function of the form 1 over log t times 4e to the t plus some arbitrary constant c, plus any number c. We're good? Let's move on to a only slightly different situation. This is the different bit. When you're given a boundary condition, right here we're told that when x is 1, y is 4. What is the job of that piece of information? What does it get you?
The constant.
Right. So we know that when we're finished with the general solution, right? The general solution is the ones that have the pluses in it, right? We will then move and use this information to find out C is 10 or 0 or 42, whatever it ends up being. Now, in this case, I'm going to divide everybody by x squared to get it into its standard form, which means get the derivative on its own. I hope we're all pretty comfortable with that process, right? Divide everybody by whatever that happens to be, in this case, x squared. And we can now identify who the p of x is and who the q of x is. Have you noticed I've tried to do every single one of these questions as if it was the same question? You notice I'm tackling it the same way. When you've got something as messy as this, I think it's very helpful if you have like a shopping list, right? Number 1, number 2, number 3, number 4, number 5, right? Because if you have that, then you only need to say, okay, what do I do next? Right, I've done that. Now what do I do next? Done that. And that kind of makes the flow a lot cleaner. And some people just like to jump right in and, you know, try and do it all in one go. And for me anyway, that's kind of dangerous because I tend to screw up if I do too many things at once. So in this case, my next step would be to find the integration factor. Seems to be a lot of logs today, isn't there? What does this guy simplify to? And he's not 2x.
X squared.
Okay. Are we getting a little bit more comfortable now with the E a log involved? Because that seems to be a common theme in quite a few questions, right? Now that's just experience, right? The more times you see something, the easier it is to figure out what the thing's going to become, right? So you see 5 log x, that ends up being x to the 5. You see a half log x, it ends up being x to the half, things like that. And now we should be able to at least start the solution. It's this fella, an integral and it's 1 over x squared, the integral of x squared times this guy there's something magical about what happens in this process. Do you notice that these cancel and we're now left with that guy, right? It's quite common, isn't it, this integral that could be really, really ugly tends to not be, tends to be quite simple. Of course, I do have a little side issue, which I'm going to do now. I need to know what that is so I can write the answer down, which I'll kind of do down here once I find out what it is. What technique am I going to use to integrate the log of x? I can tell you right now, I know we've done this exact integral when it, way back in the day.
Look at the sheet you gave us.
Well, okay, that would be one way, but let's do it from scratch.
Would it be by parts?
It would be. If I rewrite it as 1 times log of x, does that help any? Integration by parts. Now, when you do integration by parts, you have to choose who is the f of x and who is the g of x. Normally, isn't the first guy f and the second guy is g, because that tends to be what it is. But not every single time. And this is one of the not every single time. Which one of those two, the 1 or the log x, is in fact going to be the f of x in this case?
The log.
Yeah, so that's going to be the f, and this guy's going to be the g. And so it's f of x, capital G of x, take away the integral of f dashed x, capital G of x, d of x. So we have a log x times integral of 1, which is x. Take away the derivative of log x times the integral of 1. I like to put the x's first, so I'll rewrite that like this. This becomes the integral of 1, and the integral of 1 is just x. So we have x log x, take away x, plus c. We happy with that one now? Now, normally that would be the end, but can I remind you, this one had the boundary condition, didn't it? It had a y of 1 equals 4. That means when x is 1, the y is 4. So let's use that. 4 when x is 1. So 4 is 1 over 1 squared is 1. Log of 1 is nothing. So it's basically -1 add c. So if you add 1 to both sides, c ends up being 5. So our solution, our final solution, called the particular solution, is x log x, take away an x, add a 5. And we call that situation the particular solution to a differential equation. And the one with the plus c is called the general solution to the differential equation. So this differential equation up here, if you are told that y of 1 is 4, there's only one function in the universe that solves this equation, and it's this one here. Any questions? We're good? Excuse me. Have you noticed that we have to be aware of algebra? You know, how you do with things like e, the 2 log x, we have to deal with that kind of situation. Secondly, haven't we got to remember what techniques you need to integrate a function? Is it going to be a u sub, integration by parts, just a power rule perhaps, if we're really lucky? Version of question 9. This is our second last question for today. After this, we just get one more to do. Right, look at this differential equation. What do I need to do first?
Divide by t over 3.
Okay, so this guy becomes what, 3 over t? And this guy is just ugly. You all comfortable about that? Every step, virtually every question had that step in it. We'll identify the p over t, and we'll identify who q over t is going to be. What would the next step be? What would I do next?
Find ix.
Okay. In this case, I have t, but I know what you mean. And if you see something enough times, it just becomes easier. E to the 3 log t can be simplified. What is e to the 3 log t?
T cubed.
But you agree that was a lot easier than the first time, right? By the time you've seen 3 or 4 of them, it just gets kind of obvious what to do. So the next step would be to solve using our formula. So 1 over t cubed, the integral of t cubed times q Oh, isn't that pretty? the t cubes cancel, and I'm just doing a cosine. So I have 1 over t cubed, 4 sine t plus c. And that would be the general solution if that's all they wanted. But we have a boundary condition to take care of. So just rewrite this guy. And the boundary condition was y of pi equals 0. So when t is pi, y is 0. So put a 0 there. 1 over pi cubed, 4 times sine of pi plus c. What number is the sine of pi, or 4 sine of pi?
0.
Right. Don't know why this can confuse people. Doesn't confuse me, but other things confuse me. What is c in this case?
Would it just be 0?
Yeah. Do you know what some people think it is? And I'm not quite sure what's going on in their head, but they think it's pi cubed. I don't know if that was crossing your mind or not. It's not. The answer is 0. Okay, so we now have 1 over t cubed, 4 sine t plus 0. Of course, nobody would write plus 0. In fact, I would probably write it like that. Are we good? As far as things go, I would say these kinds of questions are very procedural, right? They're just a process, 1, 2, 3, 4, or 1, 2, 3, 4, 5, depending on the context. But the process doesn't really alter much. So if you understand what to do and the order to do it, you should be fine. So I said that was our second last, which it is. I said this to the other class because since this is the last question, I always feel kind of sad and kind of anticlimactic. Shouldn't the last question be phenomenally interesting or really weird so that it sticks in your head? But it's none of those. The last question that we are going to tackle is this one. I'm going to do a little bit with you. You're going to help me. What do you think I should do to both sides next? What should I do to both sides?
Subtract y.
Great. To me, it's a good idea just to take things in small chunks. Would you agree it's a little bit closer to what it needs to be? Again, same question. What should I do to both sides now?
Divide by x.
Would you agree that that's step one finished now? It's in its standard form. Okay, you have 5 minutes You finish it. Okay. Just double checking my watch. If you do it correctly, it should come out quite nicely. Do you think you've got it, Alec? Oh, okay. We've got 1 minute to go. Do you think you've got it, Mia?
Yes.
Did the IXQX bit come out nice?
Yeah.
That's a good sign. If the IXQX didn't come out nice, have a little look at your I of X again. Especially the fact that that's negative. Okay, here goes. We're starting here. The P of X is negative 1 over X. That negative is important. The Q of X is just that ugly guy there. The integrating factor then is e to the integral of this guy, which is negative log X. What does e to the negative log X simplify to? And it's not negative X.
1 over X.
Okay, 1 over X is totally okay, or X to negative 1, I don't care which, they're both correct. So when we,
For the record, I wrote both down on my paper. Just so you know.
you're taking no chances. So step 4 then is 1 over this guy, the integral of this guy, ixqx, and a c. And well, you can do it either way. If I decide to write it this way, then it's going to be x to the negative 1 times 3x sine x dx add c. 1 over a negative power is just the same as x. This guy and this guy play well together because essentially you end up with 3 sine x. And integrating a sine gets you negative 3 cosines. And now we have a boundary condition, which says that when x is pi, y is 0. So it's going to be pi negative 3 times the cosine of pi add c. And the cosine of pi, I believe, is negative 1. So that gets you 3 plus c. And then, oops, it basically tells me that c is negative 3. Right? So I have x times negative 3 cosine x minus 3. And for style point purposes, I would probably pull out negative 3 as a common factor.